Okay, so if you can remember, we have started metallic bonding, and I said it's just like covalent and ionic bond. It is an electrostatic force of attraction between positively charged metal ions, lattice of metal ions, all these positively charged ions. And I made a story last day, if you can remember. I said sodium is 281, and this one electron in the outer shell of sodium, it's problematic child for sodium, and the mother sodium, that is the nucleus of sodium, is not taking care of this child properly. So this one electron, outer shell electron, it roams around, delocalizes from their shell, and they can move throughout the structure. So they are free to move. So we call them delocalized electrons as they move from their locality. And we say these are sea of delocalized electrons. Why sea? C means a big sea of delocalized electrons, because there will be many metal ions, and for each metallic atom, you will have one delocalized electrons. So all these delocalized electrons will make a sea of delocalized electrons, where this lattice of metal ions will float, and that is how this structure is made. Any question after this? Hello. No one want to talk?
Got it, sir.
Okay, very good. Got it. Thank you. So that will be enough. If you just say got it, since I cannot see you. Very good. So metallic bonding, we have given you the definition. It is an electrostatic force of attraction between positively charged metal ion and negatively charged sea of delocalized electrons. So that is the interaction, delocalized electrons, and the electrostatic attraction between positive and negative charge is like this. Okay, and say for example, instead of sodium, if you have say aluminum, which is 13 atomic number, what will be the charge on metal ion, and what will be the number of delocalized electrons per atom, Afrin? What will be the charge on metal ion, and how many delocalized electrons will be there per aluminum atom?
The charge will be positive and 3 delocalized electrons.
And the charge will be 3 delocalized electrons, and the charge will be
3 plus.
3 plus. Very good job. So aluminum 3 plus. All the ions, say if you are asked to draw, you need to write aluminum 3 plus, or you need to give this 3 plus, 3 plus, 3 plus, 3 plus, 3 plus. Do you understand? All of them will be 3 plus. So the charge on metal ion will be 3 plus, and the number of delocalized electrons per atom will be 3 delocalized electrons, right? And since the charge on metal ion is 3 times higher than sodium, sodium is 281, and how many delocalized electrons will be present in a metal? It depends on number of electrons in the outer shell. So that is important. And so aluminum 3 plus and sodium, if we compare, you see, you will find aluminum's melting point is almost, will be many times than sodium, since the charge on delocalized electrons are more, and charge on metal ion are more, and number of delocalized electrons are more. So the electrostatic force of attraction in aluminum metal will be much more stronger than sodium. And if you see magnesium, it is 12, so it is 282. So see, number of delocalized electrons per atom 2, and the charge on metal ion will be magnesium 2 plus. Is it clear, everyone?
Yes, sir.
Okay, and moreover, if you compare, sodium will have sodium, potassium, and aluminum. Sodium metal will have the lowest melting point and boiling point. Magnesium is moderate, and aluminum is highest because of the charge on metal ion and the number of delocalized electrons present. It means electrostatic force of attraction is strongest in aluminum and weakest in sodium. বুঝা যায়? Melting point, boiling point মানেই হচ্ছে we want to separate magnesium metal ion from their delocalized electron. We want to separate these two entities. And to separate these two entities, we need to give most energy in case of aluminum and least in case of sodium. Iftikhar, ঠিক আছে?
Yes, sir.
Okay, very good. So let us proceed then. These are these they have said here. If you can, if you want, you can read. Physical properties of metals. We have just completed physical properties of giant covalent. We have completed physical properties of giant simple covalent. We have completed physical properties of giant ionic, and now we are starting physical properties of metals. Number one, metals are hard and have high melting point. This suggests that the electrostatic force of attraction between the positive ions and delocalized electrons are quite strong, right? This is number one. So since the electrostatic force of attraction are quite strong, unlike intermolecular force of attraction present in simple covalent substances, we can say these metal ions and delocalized electrons are attracted to each other quite strongly by their electrostatic force of attraction. So it is not easy to separate them. That's why they have high melting and boiling point. Number two, in the case of sodium, it I already discussed. It's not number two. It's the explanation of number one. Okay, then number two is metals, they conduct electricity. Why? Because they have delocalized electrons which are free to move throughout the structure. খেয়াল আছে কোন দুইটা পয়েন্ট থাকলে ইলেকট্রিসিটি কন্ডাক্ট করবে? কি থাকতে হবে? ইলেকট্রিসিটি
Metal is molten.
Okay, no, metal, even at ionic compound, what you are saying is ionic compound. Ionic compounds, they must be in molten or in solution state in order to conduct electricity, because in solid state they do not have free ions. Iftikhar, ঠিক আছে? Ionic compounds, এটা আমরা ionic compound এর ক্ষেত্রে বলছি, বাট সলিড মেটাল তো ইলেকট্রিসিটি কন্ডাক্ট করে। তোমার কপার ওয়্যার কি সলিড না ইফতিখার? ওই যে ওয়্যার গুলা তো কপার ওয়্যার, এগুলা তো সলিড, তাহলে ইলেকট্রিসিটি কন্ডাক্ট করে কিভাবে? বিকজ metals can conduct electricity both in solid form and in liquid form. Liquid form তো করবেই, but solid form এও electricity conduct করে, and that is the only differentiating point between an ionic compound and a metal. Metals can conduct electricity in solid form. Ionic compounds cannot conduct. Ionic lattices or ionic crystals, they do not conduct electricity in solid form. So in order to conduct electricity, either an entity must have free ions or free electrons. This is true only for ionic compound, because ions are present in ionic compounds. But this, for metal, you see they have delocalized electrons which are free to move, So that's why they conduct electricity. Even in solid form, these delocalized electrons, they can free to move. They are free to move, right? Iftikhar?
Yes, sir.
Okay, very good. So that is it. If they ask, they will often in your past question paper you will find 2 marks they will give, and they will ask why metal conducts electricity. Explain. What you will say metals have delocalized electrons in their structure which are free to move. Metals have delocalized electrons, mark 1, which are free to move, mark 2. Easy?
Easy.
Just with one sentence you will explain, and you are getting 2 marks. Very good job. Next point, number 3. Metals are malleable. Malleable means what? They can be bent to any shape. Say for example, তোমরা দেখবা ওরা হচ্ছে যখন বিল্ডিং কনস্ট্রাকশনের সময় তুমি যদি দেখো ওরা হচ্ছে আয়রনকে ফোল্ড করে, তাই না? হ্যামার করে ফোল্ড করে না? and তোমার বাসায় যত metal আছে, including your metallic mobile phone, say, and all the metals you use, spoon থেকে শুরু করে যা আছে, all are metals. How they make this shape? They bend. Metal bends, right? Metal bends. So that is the thing. Metals can be hammered into different shapes. This is what the word malleable means. Malleable means what? They can be bent to any shape. That's it. Very simple and straightforward. Is it clear?
Sir, glass can also be melted and then shaped again. So is it also malleable?
No, glass are not malleable. যেটা হচ্ছে glass is not a metal or anything. It is a mixture. It is a mixture of different things, including silicon dioxide is present. And silicon dioxide is a giant covalent structure. There are silicon dioxide particles. Along with silicon dioxide, there are other stuffs and many chemicals present. So that glass is different. Glass is different. Glass is different. So they are not, glass is not malleable in that sense. Metals in their solid form, if you hammer them, they can be bent to any shape.
Get it?
But glass ke je tumi jeta boltecho, you need to make it liquid, then you need to make, there is a manufacturing process. But metal, you take a metal,
bent.
you bend it, you hammer it, it will be bent. That's it. Okay, fine. When we apply large force, so how it is malleable? See, force. This is a metallic structure. If you apply force, see, in between the positively charged metal ions, there are delocalized electrons. And if you apply force, these metal ions, since they are in layer structure, they are layers, they are present in layers, very regular arrangement. If you apply force, they can slide over each other. They can slide over each other.
Like graphite, right?
Like graphite, but graphite is a non-metal. Graphite is not a metal.
I know that. I just
Yes, just like graphite. Very good job. Right, exactly. Just like graphite, graphite sheets are present in layer. That's why they can slide over each other. Similarly, these metal ions, they have positively charged metal ions present in a layer. The metal are in layer, positively charged metal ions are present in layer. So these layers, if you apply force, they can slide over each other to get a new shape. See, they are getting a new shape. So that is it, done. So this is one, malleable. And the next one is ductile. Ductile means you can make wire from them. You can pull them into wire. So say, for example, if you, instead of forcing this, if you pull a layer, then see, these are two layers. If you pull it, it will be a straight line, right? And this is your copper wire. Pulling is another kind of force, right? If you pull, see, a wire-like structure is formed, right or wrong?
yes, sir. Right.
So ductile is the same thing. If you pull them, or again, if you apply force, then they can be hammered to shape, to wire, and the explanation is same as malleable. Because the metal ions are present in layer, the layers can slide over each other, so they are ductile. Malleable, if we apply large force, as metal ions are present in layer, they can slide over each other, done. Again, 2 marks. They will give you 2 marks, and mark 1 and mark 2. They are present in layer, mark 1. If we apply force, they can slide over each other, mark 2, done. 1 sentence, 2 marks. Here.
Yes, sir. Clear.
Okay, thank you. So this is the end of your discussion. Everything is done. So I want you to finish these questions. And for many days, I'm not giving any homework. So this one is page number 100. Page number 100, and this soft copy of this book is given in your Google Classroom already. Just search them, those who joined late. So this is page number 101. and I want you to complete 1, 2, and 3. 3 questions only. Okay. This is all these questions are regarding metals. This chapter is very small chapter. It should be the sub chapter of any big chapter, but they have given it as one chapter, metallic bonding. So very easy stuff. ঠিক আছে, done?
Yes, sir.
Okay, so these 3 things we have completed: covalent, ionic, and metallic. Now I want to summarize the whole concepts as we have completed today's 4th classes on structures. So if you see this one, structures are easy to identify, and they are only 4: giant covalent, simple covalent, giant ionic, and giant metallic. These 4, right? So I want to give a small summarization on a table for this 3 basically: giant covalent, covalent, ionic, and metallic, and how you should know the definition that I want to just give. And they are same, as I said, they are similar. They are similar. Where is that? Okay, 1 minute. Okay, to just to give an overview, look at this slide. Can you see?
Yes, we can see.
Yes, sir.
Okay, ঠিক আছে. So see, different types of bond is I have said: covalent, ionic, and metallic. And see, all these 3 things, how will start the definition? See, it is an electrostatic force of attraction. It is an electrostatic force of attraction. It is an electrostatic force of attraction. So you see, if you understand, you don't need to memorize the definition, because this definition, any of these definitions can come for 2 marks, and you don't need to memorize even if you understand what is going on. So always, for any bonding, if they ask you, you start with it is an electrostatic force of attraction. So whatever they, in terms of bonding, whatever definition they ask, you will always start with it is an electrostatic force of attraction. The electrostatic force of attraction between what? See, between একটা positively charged entity থাকবে, একটা negatively charged entity you need to mention. So for covalent, you will say it is an electrostatic force of attraction between positively charged nucleus of the atoms and negatively charged shared pair of electrons. Is it clear? Is it clear?
Yes, sir.
Okay.
Yes, sir.
So দেখো ডেফিনিশনটা কত ইজি হয়ে গেল। ইট ইজ অ্যান ইলেকট্রোস্ট্যাটিক ফোর্স অফ অ্যাট্রাকশন, তো তুমি বাই ডিফল্ট এটা লিখতে হবে। এখন ফোর্স অফ অ্যাট্রাকশন বিটুইন হোয়াট? একটা পজিটিভলি চার্জ এন্টাইটি এন্ড অ্যানাদার নেগেটিভলি চার্জ এন্টাইটি। হোয়াট ইজ দ্যাট পজিটিভলি চার্জ এন্টাইটি? It is the nucleus of the atoms. And what is the negatively charged entity? It is the shared pair of electrons that we have explained earlier. Then ionic, again, it is an electrostatic force of attraction between positively charged ions, negatively charged ions. Done. We know positively charged ions are cations, and we have said you earlier, cat, see, cat is in inverted comma. Why? Because why cation is positive? Because we say, to remember, cat has pause. So cation is positive, cat has pause. Can you recall?
Yes, sir.
Okay, very good job. So it is an ionic bonding. It is an electrostatic force of attraction between positively charged ions and negatively charged ions. What happened? Okay, negatively charged ions. So anion and cation, it is an electrostatic. Again, the last one, the metallic bonding, again electrostatic force of attraction. Now, what is the positively charged entity and negatively charged entity? In metallic bonding, we have positively charged metal ions. You can say cations as well, because metal ions are always positively charged. So positively charged metal ions and negatively charged C of delocalized electrons. So it is an electrostatic force of attraction between positively charged metal ions and negatively charged C of delocalized electrons. Here, also that. Okay, so you can take
Yes,
a one. Done. Done.
Yes, sure.
Okay, ঠিক আছে। এখানেও সিমিলার, এটাও একই জিনিস, এখানে তেমন কিছু নাই, জাস্ট টাইপস অফ এলিমেন্টস আমরা বলছি যে কোভ্যালেন্ট টাইপ গুলা কোনগুলা, সে ওয়াটার, হাইড্রোজেন, অ্যামোনিয়া, এগুলো হচ্ছে সিম্পল কোভ্যালেন্ট। আর যেটা জায়ান্ট কোভ্যালেন্ট, এগুলো তো খুব ফিক্সড, ডায়মন্ড, গ্রাফাইট, স্যান্ড মানে সিলিকন ডাইঅক্সাইড, এই যে একটা দুইটা তিনটা আছে, দিস আর ফিক্সড, সো এগুলো তোমরা ইজিলি মনে রাখতে পারবা। Apart from this diamond, graphite, silicon dioxide, sand, all other compounds which are made of metals and non-metals and non-metals, all other compounds which are non-metals and non-metals are simple covalent. ঠিক আছে, এটা হচ্ছে number 1. Ionic bonds are formed between metals and non-metals. So any compound which is formed, any structure or compound which is formed from metals and non-metals, they are ionic compounds, sodium chloride, calcium oxide. And metallic is not metal and metal. If you mix metal and metal, they will be mixed together, and we say they are alloy, say stainless steel. So if you mix, say, copper and silver together, it is an alloy. And girls, they wear jewelry, gold jewelry, say, but gold jewelry is not made of pure gold. Rather, it is made of gold and silver mixed together. So these are alloy. Jewelries are alloy. But for a pure metal, say sodium metal, magnesium metal, aluminum metal, iron metal, what type of bonding is present? As we say, they have positively charged metal ions, and the electrons, delocalized electrons, they will make. By this, they will make. Clear?
Sir.
Any question up to this?
No, sir.
Oh, sir.
Thank you. Okay, I'm coming back, and for the next year thing, since we have completed a big chapter, we'll make a revision. Basically, I'll show you an YouTube video. There you have a good revision there for around 12 minutes video. So I think we need to have a revision, since that will be a revision for last 4 lectures. So that is important. So I want to make that a separate video. So come back and let us start again. So come now.